Well, hello there, all my 3C friends and neighbors. Welcome to the introduction to Sine Law. We are going to talk today about a very important thing, and that is triangles that don't have a right angle in them. Because let's face it, that's the majority of triangles. And if you don't have a right angle, the three primary trig ratios are completely useless to you. So we are going to fix that situation here, because I know that all the triangles that you stumble across on a daily basis, the vast majority of them do not have a right angle in them. And if you want to solve something in those triangles that you just maybe, tripped over on your way to school this morning, you're going to need to use the sine law. So our topic today, using sine law for non-right triangles, and our goal, I know how to solve for sides and angles in non-right triangles using the law of sines. Now I'm going to go crazy with my highlighter again. I'm going to take this highlighter and I'm going to highlight non-right. You can actually use sine law in a right angle triangle, but it takes a little bit more to use sine law than it does to use the primary trig ratios. So I'm just going to get straight to it. This is the sine law for any triangle ABC where A, B, and C, little a, little b, little c, are the sides opposite the angles A, B, and C respectively. That's big A, big B, big C respectively. Here's what the sine law says. The sine law says that if I take the sine of the angle and I divide it by its opposite side, and I take the sine of another angle and divide it by its opposite side, and take the sine of the third angle and divide it by its opposite side, all three of those numbers will be the same. In other words, they are proportional. And anytime you have a proportional relationship, you can solve for things. It also says that if I flip all of these over, it's the same as well, but you actually know that. You know that if I have 1/2 is the same as 2/4, that I can flip it over and say that 2 over 1 is the same as 4 over 2. You know that, right? 2 over 1 is just 2, and 4 divided by 2 is 2. So anytime, you can just flip it over. Now, these two things, the first one, it's much easier to solve if you have what you're solving for on the top of your ratio, and then you can just solve by isolation. So here, we're going to use this one for solving for the angles, which are the capital letters, and we're going to use this one for solving for the sides. So sides on top, solving for sides. And what do you need in order to use the sine law? Here's what you need. You need at least one whole ratio. Remember, whenever we solved ratios, one of those ratios had numbers in it. We need one angle side pair with numeric values. We need one whole ratio. So let's say B has a number and big B has a number. We need that. And then we need one other piece of information. One other side if you're finding an angle, or one other angle if you're finding a side. And we're just going to get straight into using it here and see how we're going to use it. Now, here's our first problem as I see it, is that I have a triangle here and there's no A, B's, and C's. How on earth am I going to use the sine law that has A, B's, and C's in it if my triangle does not have A, B's, and C's in it? What? What's that you say? Rename them A, B, and C? No, I could do that. You're right. F, E, and G, they're dispensable. I could just erase them and put A, B, and C on there. No, but I want you to get used to the idea of what A, B, and C actually mean. Little a means that it's across from big A. That's all that it means. So what I'm going to set up here, and I'm going to start by saying using sine law, because I'm not going to write the sine law down. I'm just going to say using the sine law. And then I have to find an angle. Well, what angle am I going to find? Well, first of all, I need an angle side pair with numbers on it. So here's an angle side pair with numbers on it. How do I know it's an angle side pair? Because it's an angle, and then I go all the way across the triangle, and I find a side, and they both have numbers on it. So here's how I'm going to set it up. And since I'm finding an angle, I want the angle on top. So I'm going to put that 52 as sine 52 on the top of my ratio. And then what goes on the bottom is the 25. And then I have to put another angle side pair over here. So which angle am I finding? Well, it's got to be this one, because it's the only one that has a side that has a number on it. So it's the angle F I have to find. Once I have angle F, then angle E would be easy to find because I know that all the angles in the triangle add up to 180 degrees. You remember that from years gone by. But I got to find this, I have to find F before I can find E because it's got the opposite side. So I'm going to put sine F on top here. And on the bottom, I'm going to put 21. Now, what I want you to notice is we want to get this F by itself. I'm going to underline that in red. So I need to get sine F by itself first, and I'm going to do that by isolation. I multiply both sides by that 21. So if I multiply both sides by 21, it disappears over here. Now remember that sine 52 is just a number. I'm going to pull that up on the calculator because I have to find the sine of 52, then I have to multiply it by 21, and then I have to divide it by 25. That's what all of this means. 21 times the sine of 52 divided by 25. So here's how I'm going to type that in the calculator. I'm going to do it all at once. I'm going to go 52, hit the sine button, and that's the sine of 52. Now I'm going to multiply it by 21. And that's what I get on top. And you can write that down if you want to, or you can just do it all in one step. Just do all these three things. I'm going to divide by 25. And I get 0.6. Let me get thing here. Lost my calculator. Leave it to 4 decimal places. 0.6619. 0.6619. And on this side, it's still sine F. I haven't got rid of the sine yet. Now, remember how, when we were using the primary trig ratios, how we found the angle? Well, we're going to do the same thing here. If I want to find the angle, I have to do the inverse sine of this thing. Remember what sine inverse was? It was sine -1 of 0.6619. So I have to type that in. I have to take the inverse sine of 0.6619. So I'm going to pull up my calculator again, and look, all those numbers are still there. So all I have to do is go shift. That gives me the inverse sine. And that tells me that that angle I'm missing is 41.4 degrees. 41.4 degrees. And that is my angle F. So I found the angle, and that's how you find the angle. Choose the one with the sine on top. So I'm going to go back up here, and I'm going to say this is good for finding angles. Which must mean that this one with the side on top is good for finding sides. So we want the thing that we're finding on top. On top's the place to be if you're lost, apparently. So now let's see if the next example has something to do with finding sides. Oops, I think I went too far. There we go. Using sine law to find a side. Whoa, isn't that something? Okay, again, we need an angle side pair. So here's my angle, so I need this side. No, there's no number on it. So here's my angle, so I need this. No, there's no number on it. How can I use sine law if I don't have an angle side pair? What's that? What's that you say? You know angle sum of a triangle theorem? Yes, you do. If I look at this one here, I can use the angle sum of a triangle theorem. That's a fancy way of saying that all the angles add up to 180 degrees to figure out what's in there. I take 180 degrees and I minus 67, and then I minus 72, and that's going to give me what that angle in there is. So let's take a look. 180 minus 67 minus 72 is 41. So that angle in there is 41 degrees. Now since I know this angle now I have my angle side pair. And since I'm finding a side, I'm going to start with the side on the top. So 18 on top, and the angle on the bottom is 41 degrees, but I can't just leave it as 41 degrees. It has to have the sine with it, or it wouldn't be sine law. Got to have a sine for it to be sine law. So now what do we do here? We have to find a side. Well, you know what? It doesn't actually, we can find either of the sides. So I'm just going to pick one. What do you think? Do you think E's better or F's better? Oh, no, don't all shout at once. All right, we'll go with E. We'll go with E. So I'll put E here. And on the bottom, we have sine of 67. Now remember, what we're actually finding is this side over here, because we're using this angle over here. Now, I can just type these into my calculator and get a number. Remember, sine 41 is just a number, sine 67 is just a number, but I'm not going to type it in just yet because I want to isolate this e. Now, you know how to solve by isolation. We just put brackets around and we go sine 67. Well, that's not a 7. Why didn't you tell me what that? I was going to make a mistake there. All right. Let's get that back again. Sine 67 degrees. But whatever I do to one side, I got to do the same thing to the other. So over here, I'm going to go sine 67. Now, I have to multiply this out. Sine 67 times 18 divided by sine 41. Now, I can turn these into numbers if I want to, or what I'm better yet, I'm going to let the calculator do it all in one fell swoop. So here's how I'm going to type it in. Watch carefully, and if you have a calculator that works forward, which a lot of the ones in my desk drawer do if you're borrowing that from me, you'll type it in slightly differently. I'm going to go 67, then I'm going to hit sine. Whoops, and I've got to make sure it's not second sine, just sine. So the sine of 67 is that number. I have to multiply that number by 18, so I'm going to go times 18. And now I have to go divided by, because that's what that slash means, divided by 41 and hit the sign. Now this time you have to hit equals. So it's 25.3. So 25.3 is what I get for E. And again, we should have said using sine law, but it actually says that in the example. So there we go. So 25.3 equals E, and we're done. Now what's the next one say? It says using sine law to solve a non-right triangle. So if I solve it, it means I find everything out about it. So here's what I'm going to do. I need an angle side pair if I'm going to use sine law. Here's an angle. Here's a side. I'm going to set it up. What else can I find? Well, that's a good question. The only other piece of information I have is this angle. So if I have an angle, it means I can find its opposite side, which we're going to call little r. So there's where I'm going to start. I'm going to start by setting up this ratio that I have between here, and I'm finding a side. So I'm going to put the side on top. So 22 over sine 56 equals, and side on top, so r over sine 26. And you could have wrote that one first. You could put r sine 26 and then equals this on the other side. It doesn't really matter. Now, how do I get r by itself? I hear you. Don't yell so loud. We're going to put sine 26. You know I can't really hear you, right? So we're going to cancel out sine 26 there. But whatever I do to one side, I have to do to the other, so I got to do sine 26 here. Now let's pull up my handy-dandy calculator. And we're going to type this all in. So watch how I type it in. I'm going to go sine of 26, so 26, hit sine. Now I have to do times 22, which is this number on top. And you can hit equals at this time if you want. That's what you get when you multiply the two tops together. And now we have to do divided by sine of 56. So divided by, I got to go 56 sine. And once you're done, you hit the equal sign. And it tells us that it's 11.6 is that side over there. So 11.6. Here, let's actually get the, let's not do that in red. 11.6 equals r. And actually I'm going, oh, never mind. 11.6 equals r. So now I've got two angles. I can find the third angle no problem, right? So angle Q, we can use angle sum of a triangle theorem to go 180 degrees minus 26 minus 56. So I'll just do that quick. That's 98 degrees. Wasn't that quick? I bet you didn't even see me writing it, huh? Okay, and one more thing we have to do. Now that I know that this is 98 degrees in there, I'm going to write that in green. 98 degrees in there. Now we're going to use sine law again to figure out what little q is. So I want to figure out little q. I'm going to write it this way this time. Little q, I'm going to put little q on top because that's what I'm finding. On the bottom, what goes with little q? The side across from it, of course. Here, now I got all these nice little, that's a nice little diagram there. Sine 98 degrees. And I can use either of these angle side pairs, but I'm not going to use the r just because it's rounded. It's a nasty number. So I'm going to use this one over here, 22 feet and 56. So we'll put 22 on top because it's a side, and on the bottom we put sine of 56. Now, what do I have to do? I have to get rid of the sine of 98. So I'm going to multiply the top by the sine of 98, or this side by sine of 98, and I'm going to multiply this side by the sine of 98. And those are going to cancel each other out here. So all I'm left with is q. And now let's type this into the calculator. 22 times the sine of 98 divided by the sine of 56. So 22 times the sine of 98 divided by 56 sine equals 26.3. 26.3. That is measured in feet, and it was measured in feet above 2, and we're done. And I want you to practice sine law over and over and over again. That went a little longer than 15 minutes. Sorry about that. We'll try and make it up on the next video. Goodbye.